In this question, we are required to write an ionic equation for a displacement reaction. Now, there are shortcuts to writing ionic equations for certain types of reactions. One of them is neutralization, the other one is precipitation, and there is also a shortcut for writing ionic equations for metal displacement reactions. So what exactly is the shortcut? The shortcut is this. Now, in a metal displacement reaction, we have a more reactive metal displacing a less reactive one from its salt solution. So the ionic equation will look something like this. Let's say the more reactive metal is metal 1 or M1. So the ionic equation will be made up of M1 plus the ion of the other metal, of the less reactive metal. So let's call it M2. And it's the ion, so it carries a charge and it's aqueous. And then after the reaction, remember your less reactive metal ion is being displaced to form the metal. So we have the metal of M2 and the ion of the more reactive metal, which is M1. Now for this particular example, I'm assuming that the ions have a charge of +1. This may or may not be true depending on the actual identity of the metal. So with that shortcut in mind, let's try to write the ionic equation for this particular question. For this question, chromium metal is being added to a solution of cobalt 2 sulfate. So chromium metal is the more reactive metal here. So we'll write chromium solid plus the ion of the less reactive metal, which is cobalt 2 plus. And after the reaction, we will get the metal of the less reactive metal and the ion of the more reactive metal, meaning chromium ion. Now, at this point, you may be wondering what is the charge on chromium ion, or what ions does chromium atoms form. Now, this is a small part of a larger question. In the earlier part of the question, it is mentioned that chromium forms this particular salt, chromium 3 sulfate. So from this piece of information, we can tell that chromium actually forms ion of 3 plus. So the chromium ion will be 3 plus and it's aqueous. So once again, when you're writing ionic equations for metal displacement reactions, there's no need for you to go through the very tedious process. Just remember that there's a shortcut. The metal of the more reactive metal plus the ion of the less reactive metal gives you the metal of the less reactive metal plus the ion of the more reactive metal. Now the answer doesn't stop there, because there's a very important thing that you need to remember when you are writing ionic equations, which is this, that the charges must be balanced. Okay, what do we mean by that? It means that the overall charge in the reactants must be equal to the overall charge in the products. So let's check. In this particular equation, the total charge of the reactants would be 2 plus, and the total charge in the products is 3 plus. So we can see that the charges are not balanced for this equation that we have written. So how then do we balance the charges? Is to find the lowest common multiple for the charge. In this case, it will be 6. So we need to make sure that the total charge on the left and on the right is equal to 6. So how do we get a charge of 6 plus? We need to put a 3 in front of cobalt, as well as a 2 in front of chromium ions. Once you have done that, we would have 6 plus on the left and 6 plus on the right. So the charges are balanced. But once you balance the charges, we need to go back now to balance the atoms again, because we have 3 cobalt on the left and we only have 1 cobalt on the right. So we need to balance the atoms by putting a 3. And similarly, we have 2 chromium ions on the right, so we need to have 2 chromium atoms on the left. Now, the balancing of charges is commonly overlooked by students, because even before you balance the charges, the equation already looks as if it is balanced because we have the same number of atoms of each element on both sides of the equation. So it's very important to remember when you're writing ionic equations to check that the charges are balanced on both sides of the equation.